What is going on, Ace family? Welcome back to my channel. I hope you're all having an immensely grateful day. Um, I know I am because if you all didn't know, Megan the Stallion dropped her Savage remix featuring Beyonce, and it saved us all. My skin is clear. I finally got the courage to shave, so I don't look like a drowned sewer rat like I did in the last video. So I'm feeling great. I hope it changed your lives the way it changed mine. So, anyways, I hope the first week of required learning got off to a good start. I'm ready to start our second week. I made sure to do some slightly better changes this time around. So, on each little slide, you'll see like this little box that I marked. Where's my, oh my God. You'll see a little box I marked right here, and that's for where my window can go. So on the last video, I was just waving this shit around all willy-nilly, just being very disorienting, and I'm sorry that that happened. And I appreciate people who told me about that. So I tried to mitigate that this time around to the best of my ability so that my window is either in the same spot the whole time or I know where it's going to go because I marked it with a little box. So we'll see how it goes this time. Hopefully, it's a little better. But we're moving more into chapter 2 today. We're talking about measures of center today. We're basically going back to elementary school, but it's going to be slightly upgraded just a little bit this time. So moving on, I want to talk about measures of center, and they are values that represent a typical or a central entry of a data set. So they're kind of the values that accurately describe the whole thing if you had to sum it up with one number value. And those types include the iconic trio of mean, median, and mode. They are legends. I respect them a lot. They pop up everywhere. And they're just a really good trio, kind of like the Destiny's Child of math in a way, or the Jonas Brothers of math, whoever your personal iconic trio is. They work well together, and we're going to dive into all three of them today, as if you didn't already know about most of them already, especially when it comes to that first one. But we're going to look at how they all measure up to the same data set to kind of see how they all measure something a little differently in this case. So we're going to look at some prices of some round trip flights from Chicago to Cancun. And I know this isn't a very time sensitive example because of quarantine and flights are dirt cheap right now, but let's just assume that we're out of there. It's going to be kind of a good manifestation, if you will, of better times to come. Although sky high flight prices aren't necessarily better in this case. But we are just going to pull up our data. We've got 7 different prices we're going to work with for this example. So they could range from $397 to the gargantuan crazy $872 round trip flights, and a bunch of things in between in this case. So if you're trying to be like Lisa Simpson or some other white girl who's trying to travel somewhere and change up her hairstyle, that is what we're going to be doing today. So let's just hop on our flight and let's just zoom out of here. Woohoo! Let's go. So, first one, mean. What is there left to say about mean? You've been doing it your whole lives. Again, we're back in elementary school. It's just adding up all the data entries, dividing it by the number of entries. You've done it a billion times. And I've got all of our data up in the corner right here to help out with that, just to reference. So if we add them all up, our sum is going to be 3,695. So obviously, if I want to find my mean, I just have to divide that number by 7. So our mean is going to be $527.90, which is, I would say, a pretty good, okay measure of this one, saying that's our average. It's kind of interesting because there's no value here that actually is $500, but you can see how it kind of lands in the middle, how we got a bunch of values that are lower than it, a couple of values that are higher than that. So overall, it does, the mean is doing what the mean is supposed to do occasionally. So there's that one. Second one is our median, and that is when we put all of our values in order and we figure out which one is in the exact middle. So again, Excuse me. Going back to elementary school, when you used to order them up and, cross out the one in the front, cross out the one on the side, just keep going until you get to that one in the middle. That's essentially what we're doing for this one. If you don't want to do that, there's a little easier way of doing it, of just knowing the rules behind it. So if I've got an odd number of entries, then I know my median has got to be the exact middle value. There's going to be one that's exactly in the middle where there's an equal amount on the right and an equal amount on the left. You don't have to do any extra work at all. That's the nice one to work with. Second option is if I've got an even number of entries, then you know from all those days in elementary school when you did cross, 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 you end up with two middle values in the middle. So then that means you had to take the mean of the two, where we add them up and then divide it by 2. That gives you the number that's smack dab in between them. So obviously, if I'm trying to find the median for this one, we've got to order it, right? So let's just kick that data set to the curb, and let's bring in this new set where it's nice and ordered. So we can see that since I've got an odd number of entries, I've got 7, then my median is going to be smack dab in the middle, which should be the fourth value right here. We can easily see that it's 427. If you don't want to use that algorithm of figuring out if it's an odd or even, again, you can always just revert back to the good old-fashioned cross, 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 cross. Oh, 427's in the middle. Doesn't matter to me. We're not going to focus on that too much because this is elementary school a little bit, and you are adults. You are seniors. It's just kind of a brush up on things a little bit. Last one, I would say probably the Michelle of this trio of Destiny's Child is the mode. So it's the data entry that occurs the most. So it's the one that pops up the most times. And we've got a couple options. There could be maybe 2 modes. So there may be like 2 data entries that pop up the most. There could be 1 mode. There's one that occurs more than all the other ones. Or there could be no mode, where maybe all of our data entries pop up only once, so there'd be no mode, or maybe they all pop up the same amount of times, which is kind of the same thing as the example I just said. So looking at this one, we can easily see that 397 occurs twice. All the other ones just occur once. So in this case, our mode is going to be 397. It's just one number. Well, so we got our mean, median, mode, and they're all kind of vastly different. They're all in different ranges of hundreds. The mean is way bigger than all the other ones. So looking at these, how are we supposed to know which one is the most accurate representation of a data set? Usually, most of the time, what's the one that you see the most on the news? Do they ever talk about the mode or the median all that much? Maybe so, but the most iconic one, the Beyonce of this trio, is going to be the mean, usually. It's usually the most accurate measure of center since it considers every single value in the data set. You have to add all of them up. So all the data values get to participate in this one. Whereas with the median, that one's all about positioning. So if you're not smack dab in the middle, it's kind of just screw you. You don't get to play a part. And for the mode, it's the one that occurs the most. So, you can have a bunch of data values that all maybe stretch into the hundreds, but if a super small number occurs the most, that's your mode. And that wouldn't be very accurate, now would it? So in this case, the mean is going to be the most accurate one. But, and this is a big but, sometimes it's not. Every now and then it's going to be greatly affected by a thing called an outlier, which is what I'm going to go into next. So an outlier is going to be a data entry that is way far removed from the rest of the data. So it might make a big gap in a graph. So that's saying if I've got a bunch of data values and they're all kind of around this range, an outlier is going to be way bigger or way smaller than the rest of them. So thinking about at the beginning of the trimester, when I had you guys write on note cards, the one I remember the most is, we were talking about siblings, and I think when we got to that value, our average was like pretty big, and it's because I think Cheyenne, you said that you had way more siblings. I want to say it was 9, maybe. I don't remember exactly, but that was way bigger than all the other ones, so that brought our mean way up. So that would be an outlier in this case. Another example is maybe you really love some scary movies and none of your friends are having that shit at all. They're like, Brian, we do not want to watch Scream 4 again. We're not trying to do that at all. You would be the outlier in your friend group in this case. Or we've got another terrible election year coming up. So if you live in a blue state and you're trying to vote for the red candidate, your vote is going to be the outlier in that bunch. Or vice versa. If you live in a red state and you're trying to vote blue, those votes would be outliers because they're kind of far removed from what the majority of the data is saying in this case. So let's actually see an outlier in action. So suppose we're wanting to do some type of study about ages in a college class. So here's our data right here. And as we can clearly see, something's a little off. We got a bunch of them that are all in the 20s, and then bam, right at the end, we got someone who is 65, which no judgment at all. It is never too late to continue your education. You can do it whenever you want. I'm going to tell you all right now, you're seniors, you're about to become adults, you're about to just spread your wings and dive into the adult world. It's okay to take a year off or a couple of years off because college is whack. It's a lot. It's very expensive. It's way too traditional for its own good. So if you want to take some years off, go for it. They will take your money at any age, okay? You can always come back at any time. Just make sure you know that. So here's all of our ages. Here's our data set. They're all in the 20s except for this 165, and that 65 is going to cause a little bit of trouble. So boom, we got our mean, median, and mode, and we can clearly see that the mean is way higher than the median or the mode. And I know it's only by a couple years, but in this case, since our data is all so close together, being off by 2 or 3 years is a really significant difference, especially considering that our median and mode are fairly close. They're off by 1.5 years. So what's going on in this? It's a lot easier to tell by a graph. So da 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 da, rise from the ashes. We've got this beautiful histogram, and we can see all of our data is clustered over here, except for this one data point right here. And it makes this huge gap, right? When I was talking about a gap, this is what I was talking about. So we've got all of our data here, but we've got this one data point over here. That's going to really play with our mean a lot. We can clearly see that the median and mode are kind of chilling over here, but the mean is kind of on the outskirts of this little cluster a little bit. So what outliers can do is that they can pull the mean in their direction. This 65 is just kind of sitting out here, and it's like, hey, big boy, how about you come on over here for a little bit, okay? How about you sidle up on next to me? So it's kind of moving this mean out in this direction a little bit. And in the last section, when I was asking you to look at histograms and say, okay, what conclusion can you make of this? Obviously, what you'd want to look at is that chunk of data, right, where it's all kind of clustered together. So in this case, the mean is kind of on the outskirts of that, whereas the median is a lot more centered in it. So in a situation like this, the median is going to be a better description of the data than the mean is. And that's because that outlier pulled it so far to the outskirts of the data. Outliers only affect the mean. The median and the mode, they're pretty unbothered most of the time, especially the mode. The mode does not give a shit at all. So watch out for outliers in this case. Last thing, I'm gonna take a drink real quick. I can feel my lungs being like, you're talking so much. You need to just chill for a sec. You can take this time to pause the video and stream the Savage remix a little bit if you want. Do whatever you gotta do. I can't stop you. Last part I want to talk about, and I'll leave you alone for today, is that the shape of a distribution or a histogram is going to reveal a lot about the data that it represents. And there's going to be 4 major shapes to look out for. So first one is symmetric or bell shape. This is probably the most iconic graph shape of all time. And you guys know what symmetric means. That means if I draw a vertical line through it, it makes kind of a vertical image, kind of like a butterfly or something like that. So it's usually going to look like this. It's going to be a pretty little bell curve, and everything's kind of centered right in the middle. That's where it peaks right there. So in situations like this, if your graph is symmetric, usually that mean and the median are either going to be the same, or they're going to be so close that it doesn't even matter at all. So usually data like this is going to be for something that kind of varies a little bit with each person. So if you're trying to measure like the height or the weight of people, usually the majority of people will fall in the middle, while we've got some people on the ends and some people on the other end. That's usually when the symmetric graph happens. Second shape is either going to be uniform or rectangular, and that's when all my entries or my classes, those blue boxes, are going to have the same frequency. So it's going to look something like this. And it's not always going to be perfect. Sometimes you might have a couple that are slightly taller or slightly shorter than the others, but they're all going to be relatively the same. That would still be uniform. So in this case, the mean and median would also be either the exact same or super close. Usually a graph like this is going to come from something that has an equal probability. So if you're flipping a coin or rolling a die a bunch of times and recording whatever you get, usually you'll end up with a uniform graph like this if you do it a bunch of times, because the chances are going to be the same every time. Last two kind of go together. Those are skewed graphs. And that's when they've got a little tail on the end that kind of elongates to more than one side than the other. And I'll show you the two different forms of them. I couldn't fit them on this slide. So you could either have one that's skewed to the left or skewed to the right. Our left skewed one is going to look something like this, where I've got most of my data chunked to one side, but then it's got a tiny little tail on the other side. It's skewed to the left. So we've got a bunch of little outliers here, and those guys are going to say, hey, Mr. Mean, how about you come on over here sometime? So they're kind of pulling that mean slightly in this direction. So we can see that they're not quite the same, the mean and the median are. So if your graph is skewed left, more often than not, your mean is going to be less than your median because they're pulling them in the direction of those smaller values. So on the flip side, with my skewed right graph, everything's going to be chunked on one side here, but it's going to have a little tail on the right where all those big values are. So those big outliers are saying, hey, Mr. Mean, how about you come on over here? They're kind of separating it from that median a little bit. So in this case, our mean is going to be greater than the median because those big outliers are pulling that mean more toward the big values. So it's going to be slightly bigger. So these are the situations that you've got to watch out for. These are the most iconic graph shapes. So that is all I've got for today. I hope you're all doing super well. Yeah, that's about it. So again, stream the Savage Remix, and just have a lovely day. I'm missing all of you. I hope you were all able to pick up your caps and gowns. I totally forgot that's a thing that happened. So if you didn't already know, based on our faculty meeting that we last had, they're still really pushing for an actual ceremony. They're not trying to go for a virtual one. So the plan right now is that hopefully they're shooting for something in maybe like late June, maybe July. And if things are still chaotic then we might have to do a virtual one. But right now they're going for maybe June and July when hopefully things die down. If Kim Reynolds can actually make an okay decision. We'll see about that. But I'm hoping for it. I need a good cry so I can see you all walk across the stage and become the amazing adults you're meant to be. Anyways, so hope you all have a lovely day. Let me know if you have any questions at all. Again, our office hours are going to be Tuesdays from 3 to 4. I'll have a little Zoom session. You can just pop in and say hi if you want to. It was a good time the first time. So that is all I have. So have a good one, everyone. So long. Ah, no! There we go.